Okay, over here to the right, I have defined g of x as the function that we're trying to find the limit of as x approaches negative infinity. And we can see over here from the graph on the right and the fact that g of negative 1 million is about negative 0.750001. And then it looks like the graph approaches y equals negative 3/4 as a horizontal asymptote, that the limit is probably negative 0.75. Now, when you're working with limits as x approaches negative infinity, what's frequently easier to work with is to take the limit as x approaches infinity, and then wherever there's an x in the original function, replace it with a negative x. And the result is the same as x approaches infinity for the new function as it is as x approaches negative infinity for the original function. You can see that opposite of x squared still gives us the 4x squared, but the plus 3 times minus x is minus 3x, and this plus 2 times minus x becomes a minus 2x. And so f of x is that function, and as f approaches 1 million, we're approaching the same limit. And the graph approaches y equals negative 3/4 as a horizontal asymptote. So the question is, how could I find out this negative 3/4 as a limit of this function right here? And to do that, we'll go to the second board. And the key is, what frequently works when you have a radical minus or plus a constant is to multiply top and bottom of the original function by the conjugate. In this case, a plus 2x instead of a minus 2x. And the reason is because this leads to a difference of squares in the numerator. A minus b times a plus b is a squared minus b squared. So this first term, a squared, gives us what's under the radical, 4x squared minus 3x, and minus this b squared gives us minus 4x squared. These cancel out, and we've got minus 3x in the numerator now. And in the denominator, we just have this conjugate because we multiplied it times 1. Now, to find the limit as x approaches infinity, what we can show is to divide every term top and bottom by x. And x, to introduce this x into this radical, we have to picture it as x, the square root of x squared. And now we can divide that into each term under this radical. It looks like this. 4x squared over x squared is 4. 3x over x squared is 3 over x. 2x over x is just a 2. And now as x approaches infinity, this term approaches 0. So we've got this. And if we evaluate that, we do get a minus 3/4. Okay, there you go. Hope that helped. And if you have any questions, post a comment.